Hello, 6th grade. We're going to talk about 2 new vocabulary words before we start solving equations using addition and subtraction. Make sure you have these correct notes in front of you. When we think of the word isolate in everyday use of this word, it means someone off, alone, by themselves. In math, a very similar meaning, but a specific one. So for the definition, you're going to write, to isolate means to get the variable to stand alone in order to find its correct value. When we're isolating a variable, it only applies to variables, letters representing numbers. So for example, if you were to isolate a variable, it would look something like this. W equals 14. That is a variable on one side of an equation. It's isolated, it's by itself, and it's telling me, hey, what is W? Well, it's equal to 14. Another example would be like A equals 4, B equals 0, and so on and so forth. You have a variable on one side, and then the value on the other. This is what an isolated variable looks like. You got the letter symbol on one side with the value on the other. It does not have to be in this order. It can be swapped, but it's balanced with the letter symbol and what number should be in its place. What's in the W box? What's in the A box? What's in the B box? Another example, which is what you will do with equations, is if I had, let's say, x plus 4 equals 8. If I want to isolate the variable, I want x by itself telling me what's in the x box. The next term you're going to learn about, inverse, will tell you how to do this. But for now, I'll just show you. I need to get it by itself. See this 4 hanging near it? I got to get it out of the way. So in order to do that, I have to subtract 4 from both sides. This cancels each other out. 8 minus 4 is 4, and I have isolated the variable. Non-examples would be something like the original equation. B plus 12 equals 24. This is not isolated because there's still a 12 on this side. Isolated means it's just the variable equaling a value. This is not an example of an isolated variable. All right, moving on to the next word. We're talking about inverse. So when you say inverse, I want you to think of the word reverse. Like when you're driving and you're moving forward, if you're going reverse, you are going in the opposite direction. So mathematically, the definition is the opposite in effect, or the reverse of, and then put a little star here, in the same level of power. And you'll know what I mean by that in just a moment. So I'm actually going to jump down to an example, and I want you to write PEMDAS. And we write it up and down instead of left to right because we're talking about different levels of power. You look for parentheses first, then you look for exponents. When we're talking about inverse operations or the opposite, I want you to focus that multiplication and division have the same level of power. Just like addition and subtraction, they have the same level of power. So I'm going to actually use colors to represent that. These guys are both equally powerful, just like these guys are equally powerful. They're on the same level. So the algebraic example, what inverse operations are, would be division is the opposite of multiplication. So I'm going to put the X or the dot that we've been using lately. And be sure to put the arrows like this, because they are the opposite of each other. it goes in both directions. Multiplication is the opposite of division. Division is the opposite of multiplication because they're on the same level of power. Next, I'm going to talk about how subtraction, make this a little thicker, is the opposite of addition because they are at the same level of power. So for a non-example, what I want you to draw is the same thing I drew for my example, except the arrows are going to go crisscross. Division is not the opposite of division is not the opposite of addition, and subtraction is not the opposite of multiplication. These are non-examples. Sorry. These crisscrossing are not the opposite of each other because they're at different levels of power, like I showed on PEMDAS. Multiplication and division, same level of power, they are each other's opposites. Addition and subtraction, same level of power, each other's opposites. All right, you are ready to move on. Moving on with solving equations using addition and subtraction, we're only going to worry about this lowest level of power, adding and subtracting. When solving an equation, you must first isolate the variable. It's kind of like you're cornering it. There's x in an equation and you want to corner and say, hey guy, what are you? What's in the x box? You want x equals something or b equals something. It has to be isolated by itself. To isolate the variable means that you need to get the variable all by itself on one side of the equation. Sorry, I kind of ran out of room there. But to isolate it means to get the variable all by itself, nothing else around it, nothing added, subtracted, multiplied, or divided, just alone and isolated, and telling me that's its value, whatever number it equals, that's how much it's worth. To isolate the variable, you need to move the numbers to the other side of the equation using inverse operations. You basically want to cancel out anything around your variable, whatever that may be, in order to get it all by itself. Inverse means opposite, and the inverse operation of adding is subtraction, and the inverse operation of subtraction is addition. They are each other's opposites because they are at the same level of power. I don't know how many times I got to say it, but they are at the same level of power in PEMDAS, so that's why they are each other's opposite. You'll see Miss Madera doing this with her hands. They are each other's opposite operations. When solving for a variable, it is important to, and I will require you to do this, you must show all work because I will need to be able to tell if you use the correct inverse operation and if you followed your math correctly. So once you find the value of the variable, you're just going to check to make sure that it makes sense, that it's logical. Right here, you're going to add the addition property of equity. This is basically the math law stating that when you add the same number to each side of an equation, the two sides remain equal. Remember when we talked about how an equal sign is a balance? You want each side to be balanced and equal to each other, like 2 plus 2 is the same as 6 minus 2, because both of these values are 4, they are balanced. Also, you hear Miss Madera say often, what I do to one side, I got to do to the other side. So, if I have an equation like W plus 8 equals 10, what I do to one side, I got to do to the other side. I subtract, I did the inverse operation on this side, I got to do the same to the other side of the equation. This cancels out, leaving me isolated, and 10 minus 8 is 2. There's my isolated variable value. So back to the notes. This is just the math law stating what it is. That means that the subtraction property of equity states that when you subtract the same number to each side, the two sides remain equal. What do you do to one side? You got to do the other in order to keep that balance. All right, let's try a couple together. So I have x plus 4 equals 12. I eventually want x isolated by itself. So I'm going to put this down here to remind me. I need this and a value on the other side. But there's this 4 in the way. I got to get this out of here. So I need to do the opposite of addition, which is subtraction. What am I going to subtract on both sides? Well, I need the 4 gone, so I want to get rid of 4. What I do to one side, I got to do to the other side. This results in 0, or you can do what Miss Madera does and just they cancel each other out, leaving this guy isolated over here. And then 12 minus 4 gives me, anybody? 8. Pause for effect. This is the last step to check. You're going to plug it in. You had x plus 4 equals 12. I know you guys can solve this using mental math, but I have to see you check your work that you followed each procedure. So I'm going to take my 8 and plug it in. And now I check to see if this is true. 8 plus 4 is 12. 12 equals 12. This is true. This is a solution. All right, let's try one more together. I have x minus 5 equals 25. I want x isolated by itself. You don't have to do the arrow every time, but I'm just showing you this. This is where I'm getting that number, or excuse me, that variable. This is what I need, an isolated variable and a value. But I got this 5 in the way. I got to get this out of here. What's the opposite of subtraction? Addition. I need to add 5 to both sides because I want to get rid of this right here. So in order to do that, I need to do the opposite operation with the same number. This cancels each other out. 25 plus 5 is 30. That is my isolated variable. So now I'm going to check. I have x minus 5 equals 25. Plug it in. 30 minus 5 equals 25. 30 minus 5 is 25. It is equal. It is balanced. All right, you are ready to move on.